I am Bilal Masud from Center for High Energy Physics, Punjab University, and what you are watching is the first video of a physics course. The name of the course is Quantum Mechanics Made Clear, and quantum mechanics is a comprehensive theory, and that can be and is very much now used to explain every kind of phenomenon, but it's a difficult theory as well. So unless you really need it, unless you don't have any alternative to it, you will not use it. And in case of daily life means visible size things like a bone or anything, or somewhat smaller means you see it in a microscope. Audio microscope, you see cells, and then you see in electron microscope, or you just read about its models or explanation of what science says about its parts and parts of parts, and so eventually you will reach a size scale which is called microscopic, that you can word the word you can use for atoms, molecules, and then electrons, and then what do you know about it. So eventually if you read that, and there may be a ultimate structure which maybe not everyone knows, the present is till quarks and so on. So for this from atom, molecules, and smaller things, there's no alternative. You have to learn quantum mechanics. There's no other thing known in present human knowledge. So that's why if you have to understand atoms, this means if you have to understand many apparatus which use atoms, because atoms are small but their number is large. There are very large number of atoms. So all in all, they make a thing which you net the collection of so many atoms that you see sometime in terms of CD, DVD player, or electron microscope, or laser diode. And for these kind of devices and many others, if you use classical mechanics, means ordinary physics, which is called Newtonian physics or classical physics, you can say common sense physics, that will not work. You have to learn quantum mechanics for these applications. And now about educational aspects of that. So this is what you are watching is a physics course, is not popular science, is proper science education. Although this particular playlist this is composed of shorter videos, and which means here you'll be told results which you can use even at university level for preparing interviews and things like that. But if you are talking for preparing for exams, or say in detail where you have to answer long questions, then you should prefer the other playlist, not this. The other one is Quantum Mechanics Made Clear with details. So if you don't want mathematical, if you want less of mathematical details, then you choose this one. Anyway, for that or this, for both, prerequisites are same for both. And I hope these prerequisites are taught at intermediate level, and in American technology means high school level. I hope these are what you know: linear momentum, angular momentum, kinetic energy, potential energy, total energy definitions, and Coulomb law, expression for force as well as for potential energy, and expression for simple harmonic potential energy, namely half k square, and photoelectric effect in the sense that energy of light means photons. Energy of light is discretized, and units are called photons, and every unit energy is proportional to frequency: violet more, red less packet. And then there's photoelectric effect. Maybe if you have not studied, you can read any book or article even now, and hopefully you can understand. And another work of Einstein, photoelectric effect also of Einstein, that theory of relativity, and in that you have a moving mass. A particle has a very speed comparable to speed of light. Then its effective inertia means mass increases. So that you formula, if you know, and that's all. Which I think does not require any college or university level of physics. Okay, as for math, if you have even an intermediate level, if you have chosen high school level, if you have chosen math, then hopefully you know matrices, determinants, and calculus, and that limits, differentiation, integration. Maybe you need some higher education for math for that, and that's the start. From here, this course takes you to a full-fledged quantum mechanics course of, in my case, it is a 4-credit course which I taught for last 15 years. Okay, now out of that means composed of 27 lectures or so. The first one is on wave particle duality. If you have heard this name, that's a good. Otherwise, this particular lecture is to introduce you to the what is wave particle duality. But the mental training is that you should understand that science is explanation of observation. And observation means visible effects. Sometimes you think that observation means a thing. Okay, that works if you are talking about moving ball. But if you are talking about bullet, then observation means practically only its effects where it strikes. And in case of light, think of that. You see only when light strikes or you use its path. Think of that, but let's see as the lecture goes. And then, if you have thought about that, then you should be able to understand or discuss or start a discussion whether electron or photons are like particles like a ball, or they are like waves, whatever. Waves, at least water waves or light waves. We have to discuss whether light is a particle or wave. But wave prototype is water waves or waves on a string. Okay. Now start with a simple thing. It is so simple. It doesn't. Simple means it's a basketball. It's so simple. You think it's easy, but in a way it's problematic. Because of basketball, you think the 3 questions are same. One is what is basketball, the other is what is the path of basketball, and the third is what are the visible effects of basketball. But you do not start learning making a difference between them. But I hope through example of bullet, you start thinking about that these 3 things may be different. Visible effects means where bullet strikes, and that practically you see only that. As far as path, practically you can't see unless you use a high-speed camera. You can see the path, but if you want to understand this course of quantum mechanics, start learning that do not depend upon your knowledge of the path. If the path is not measured, if the path is measured, then it will be a different thing. But if path is not measured, and if you know only effects, still your mind should work. Anyway, start thinking. If you know only effect, will you stop thinking or continue? You should continue. And this lecture onward is I am to encourage you. You should think in any case. If you see any fact, explain it. Whatever it is. It may not be a path. Okay, next come to light, where first you have to see whether the path is visible or not. And you may think that you can see the trajectory of light path, but actually not. In some situations, it's very clear that you see only effects of light when it strikes, and visible effects that. You may be thinking that it's possible to see the path of light. Okay, I can say apparently yes, but for that you have to change experiment. For example, if you see light coming through a window in a room which has dust, you may think you have seen the path of the light, but actually it's not. The lesson is same. Here the light strikes and you see where it strikes. Here the only difference is the light strikes on dust particle. So what you are seeing is dust particle, not the path of light. You should start, at least light is also trains you to infer, to conclude, to make a lesson only from your knowledge of visible effects. And visible effect where lights, like bullet, strikes, not path. Okay, you can, if you make a technology, you can see path, but do not depend upon that. For example, this is an experiment which is actually a topic of lecture number 3. So if you don't understand, don't be discouraged, but still at least I ask you, whatever it is, if you see only effects on a screen, will you be able to conclude what is the path? For example, if you see two vertical set of dots, what will you conclude? I think you will conclude that whatever it is, it passed through like bullets. But in case of actual electron, what happens is, this is something from lecture number 3. So this is the end of lecture number 1. So if you don't understand, don't be discouraged. But if you can have some feeling, then that will help. You see, there are not two vertical bars. They are not same. They are dots. These are dots, but these are scattered like. Have you seen that pattern? Have you seen water waves? You know, rise and fall and see. This is also rise and fall. In case of light, it's a more sophisticated technology, and that's it. Here you see rise and fall like water waves. So distribution is like a wave, and every dot is like a particle. Is it a contradiction? Is it two different answers? That's the conclusion of this lecture, is that it's not. Okay, dot is a particle, and distribution of dot is a wave, but that is not a contradiction. They are different, but because the questions are different. If your questions are different, answer will be different, but that is not a contradiction. And that happens in, for example, for a person, you can ask two different questions: what is the birthplace or ethnicity of a person, and what the person does. And in my case, if you ask about my birthplace or ethnicity, etc., there can be many ways of answering. And for example, I can say I'm Asian. And what I do, I can say in a variety of ways. And for example, I say I'm scientist. So I have two different things to tell you about myself, Asian and scientist. Will you like to say it's Asian scientist duality? Maybe you say, but at least think it's not a contradiction. But I think when people tell you this kind of thing, that electrons sometimes waves as it behaves, sometimes as particle, and then do not tell you what is the rule that decide when it is a wave, when it is a particle, then I'm afraid that you may conclude, or you may get impression that it's simultaneously wave and particle, and hence it's a contradiction and so on. So it's not. So I think that lecture was to tell you that it's not a contradiction. There are two different answers, or two different questions. So that is what normal logic is. So the rest is in coming lectures, and to remain aware of that, you must subscribe to this channel, and so or otherwise, I hope we meet in the next lecture in 2 days time or so.